All right. So October, November 2019, 9608 P22. Let us start. Question number 1. Study the following pseudocode. Procedure fill tank declares tries integer, declare full as boolean, tries is equal to 1, initialize full is equal to read sensor f1. So whatever this function does, it returns something in boolean that is received in full. If not full means if full is equal to false, then while not full and tries are less than 4, called top up, and it goes on until full is false and tries are less than 4. So if tries are greater than 3, once it gets out, then output too many attempts, else output tank now full, and if else output already full, and if and procedure. The pseudocode includes features that make it easier to read and understand. Okay, read and understand. Okay, so few of us, what they do, they say okay, it is structured, it is calling subroutines and all. That is good programming, not good reading. Making program easy to be read does not include subroutines. If it is just one program, yes. If it is number of programs and you are trying to make someone understand the structure of the program, and there is a structure chart, and then there are pseudocodes, top-down approach and all. But for this such little pseudocode, we have to see if keywords are in uppercase, there are blank lines in between, there is good indentation, there are sensible variable or identifier names, all keywords are in uppercase. That is something that makes you understand the code easily. So features are indentation, auto indentation or indentation, whatever that you write. It is indented code. There are blank lines. There are blank lines. All right. There are blank lines. There are sensible identifier names or variable names. Capitalized, capital keywords. These are the features. Okay. Now, draw a program flowchart to represent the algorithm implemented in the pseudocode. Variable declarations are not required in the flowchart. Okay. So let us start. Then tries is equal to 1. Tries is equal to 1. Since subroutine is being called, so we will use a different box here for subroutine. Full is equal to read sensor with F1. And then we have got check is full is equal to true. Not full means if it is true. If it is true, then while not full, again, is full is equal to true and tries are less than 4. Okay, yes. Then call top up, call top up, and full is equal to read sensor F1. Okay, tries is equal to tries plus 1. If tries are greater than, try is equal to tries plus 1, and then loop ends. Loop ends then. Okay, and then if it is no, then it gets out is tries. Now we are here. If tries is greater than 3, yes, then output here, too many, no, output tank now full. Okay, this ends. Now this is the end of this one. We have finished until here. Then we have else over here. No, output already full, and then it ends. So from here it goes at end. Okay, so this is our flowchart. Exact same flowchart. Okay, so tries are initialized, full is initialized by calling a function. Then it checks that if the full is true, if it is true, then it goes inside a loop. There we go. This is the loop. This is the loop. If loop ends or the condition is not true right at the front for the loop, then it goes to this area. Once the loop ends, then it goes to this area anyways. And meanwhile, inside the loop, after the loop, inside this if true condition, there is also a check for the tries if they are greater than. Then there are two outputs according to those checks. Once this condition is done, then it is ended. Otherwise, if condition is false, then it goes to this output over here. That output is done. So this is parallelogram. Be careful. This is parallelogram and then the program ends. So this is perfect flow chart. You get 5 marks for it. Now, part B. Programming languages support different data types. Complete the table by giving suitable data types. So this is integer. This is Boolean. This is real. This is a string. Why it is a string? Because it is actually enclosed in double quotations. Evaluate each expression in the following. If an expression is invalid, then write error. Okay, right of stop 3. So we take top, merge with left of h2. So this becomes top ik. This is the answer. Mid num2 string. So we have made this 2019 a string. So from its third character, we take 1. So that is 1, but that 1 will now be string because mid only works on a string, and we had already made this 2019 as string. So first we made this 2019 as string, and from its third character, we picked up 1 character from the middle, that is 1. Num2 string. So this has become minus 273.16, and then we turned it back to an integer. So this will become minus 273, but no. So since we have made it a string, we cannot get rid of this decimal part from the string with integer. So this is an error. So get the idea? This is a real number. First, we turn it to a string and then apply integer on it. So we cannot apply integer on a string. This is what it is. Okay. So now this is integer. What integer does, it gets rid of the decimal part. So 13 over 2 will become 6.5, but when integer applied, this will become 6. This is not round, this is integer. It doesn't round, it just shades off the decimal part, point value part. Describe the program development cycle with reference to the following: source code, object code, corrective, maintenance. Okay. The source code is the program in high-level language written to solve a problem. Okay. Object code is generated out of source code or it is translated from the source code using a compiler Remember, interpreter does not generate any object code. It does execute it only. Corrective maintenance corrective maintenance is carried out when a program does not behave as expected, maybe because of poor analysis of the solution. All right. Program development life cycle has all these covered as it is an iterative process required to analyze, design, code, debug, install, train, maintain the solution. Okay. So program development lifecycle has all these covered as it is an iterative process required to analyze, design, code, debug, install, train, and maintain the solution. Okay. Give three features of an IDE that can help with initial error detection. Okay. So initial error detection is first of all done with syntax check or dynamic syntax checks. As soon as you write a single line of code and you enter it, the syntax is right away checked and you are um, uh, told about it. Okay. Uh, Auto indentation, auto correction, pretty print, system informs, system as in IDE informs for any unused variable. Remember that green line under the declaration in Visual Basic that actually tells that these are the variable that you have declared but you haven't used now. Okay. All right. And that's it, I think. We have written 5 out of 3. Okay, a student is developing a program to search through a string of numeric digits to count how many times each digit occur. Okay, so search through a string of numeric digits to count how many times each digit occurs. The variable in string will store the string in 1D array. Result will store the count values. Okay, each check each character in the string to count how many times each digit occurs. So this will be something you have got an array 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, and 10. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, and we are having 0, 1, 0, 1, 2, 3, 1, 4, 1, 5, 8, 3, 2. Let's say this one. So system will read each character in this string one after the other. Let's say if it is 0, this will be made 1. If it is 1, it will be made 1. Then 0, it will be made 2. Then we have got 1, then it will be made 2. So then we have got 2, we make it 1, then 3, then 4. Then again 1, it is now 3. 3 times we have encountered 1. Then 5, it is 1. Then 8, it is 1. Then 3, it is now 2. Then 2, it is now 3. Sorry, it is now 2. So what is basically happening that we have got one string, we are starting that screen or scanning that string and reading that string a character by another character. Once that is done, we then go to that respective element in the array, as we are actually seeing this array as a counter for these digits in this string. So ultimately we would have in this array at the respective element index that how many times this particular character, which is basically 3-digit, occurred in this string. Okay, so this is what it is. The variable in string will store the string, and 1D array result will store the count values. The program will check each character in the string to count how many times each digit occurred. Record the count of each digit using the array. Output the count of each element of the array together with the corresponding digit. The result is 1D array of type integer. Write pseudocode to declare array and initialize all elements to 0. So first we have to pseudocode to declare the array. So declare result as an array from 0 till 9 of integer. Declare I as integer as well. So we will use this I as index for. So now for I is equal to 0 to 9, result I is equal to 0. We are initializing it and then next. So you get the idea. We declared this array, we declared the index, and that for index, we have run through the loop and we initialized every single element to 0. Write pseudocode for the program, declare any variable you use. Do not implement the code as a subroutine. Do not implement the code as subroutine. So we will just write the program. All right. So we need to, let's say now the array is declared and it is initialized. Okay. So in that in string thing that they said in string, this is a variable that is made and let's say it is available. We have got no idea from where it got filled and who filled it and if it is global or not, but we just take it for granted that it is there and it is made. So declare this character. We will use this particular variable to read one character at a time. We will declare I for index and I for index, and we will use that particular, let's say, as integer. Okay. So now for I is equal to 1 to length of in string. All right, then pick up a character. This character is equal to mid of in string I comma 1. Now we will go to that particular location at the array, in the array rather, and we will increase the count. Okay, so now the name of the array is result Let's make another variable. Call it position. Okay, first, whatever the digit that you have extracted from in a string, let's convert it to its integer format. A string to number function. This function is usually given with that insert in exam. So now let's say we have picked up 0. Okay, let's say we have picked up 0. So now this position will be now 0. We will simply go to result position is equal to result position plus 1, whatever the value. If it is not yet encountered, then there will be 0. If it is, then there will be any other integer. But whatever the value that will be there at that particular element will be increased by 1. Okay, so this will be continued for the whole string, and every character that is picked is first being converted to its number format, which is integer, and then at that particular location the count will be increased, and then we have to output all of it. For I is equal to 0 to 9, and then we will output num2 string. Now num2 string I merge with num2 string result I. So whatever the count will be there, that will be output. Okay. Next, I. Okay, so now what is remaining? Only initialization. This character is null. Position is equal to 0 and I is equal to 0. So this is your complete code that will be actually reading one string. Okay, so let's say I have got this string. In a string 1 2 1 3 4 1 5. Okay, so now what will happen for I is equal to 1 to length of any string? So this is 1 2 3 4 5 6 7 characters length. So this loop will work 7 times. This character will pick up 1. Convert this 1, since it is extracted using mid from this string, so 1 will be string as well. So we converted this 1 into its integer form using string to number function. So position will be 1. So result 1 is equal to result 1 plus 1. So let's say we have got this array result 0 1 2 3 4 5 6 7 8 and 9. So they all are initialized to already 0. So we picked up 1. So system will go at 1 and count 1 there. Okay, this way. Then 2 will be picked up. System will go at 2 and make it 1. Then 1 will be picked up. So this 1 will now become 2. So that is how it will go on and on and on and on and on. And once that is finished, it system comes out and will output I, which is in a loop 0, 0. Then 1, 2 times. 3, oh sorry, 2, 1 time. 3, 0 time. 4. That is how it will output the whole thing. So that is how it works.